So we are having two types of bond. Number one is sigma bond and another is pi bond. Now first of all, sigma bond. What is sigma bond? It is a bond which is between the covalent bond. These both are the bonds by which the covalent bond is shared. Like this is axial overlapped, axial overlapping of atomic orbitals. Now what is overlapping? Overlapping is like a word that is used to be overlapped. Like in previous videos I've told that covalent bond is like sharing of electrons. But the sharing electrons, because electrons are present in the orbitals as we all know, so that electrons will be shared by orbitals, so that orbitals will be overlapped or orbitals will be joining, so that will be word used, that overlapping, for joining of the orbitals, so that will be word used, overlapping. This is axial overlapping of atomic orbit, like the atomic orbitals will be axial overlap, so that will be called the sigma bond. Like here we are having p orbital, here we are having p orbital. Now they will make, when they will make bond between them, it will be like this. So that's called the axial overlapping. This is also called the head-on-head overlapping. Head-on-head overlapping. The sigma bond will be mostly, or we can say always, be made on the x-axis. Like you can see here, this is x-axis, there is an axial overlapping of atomic orbital. After that, for example, now first of all, pi bond. What is pi bond? It is parallel overlapping of atomic orbitals. Like we are having, this is a p, this is also the p. So when they will overlap like this, or we can say side by side overlapping, this is a parallel overlapping, this is called a parallel overlapping, this is like parallel. So that overlapping, parallel overlapping of atomic orbitals is called the pi bond. The bond between the parallel overlapping, that is called the pi bond. Like here, this is a bond, so that will call the, here this is a side, this is also a side. So the side on side overlapping will be called pi overlapping. Here as you will see, first of all, the overlapping between the s and s orbital. Like when s and s orbital will overlap, so which bond will be there? Like here we are having s, as we all know that s have a spherical shape. This is s. When they make bond with another s, so the result will be like this. Like this. This will be called sigma bond. This will call sigma bond. Like you can see here, this is a head-on-head overlapping, or we can say axial overlapping. So that will be the sigma bond. Now if we talk about the overlapping between p orbital and s, like this. Like we are having this one as spherical shape, and P is having double shape, so it will be like this. So the overlapping will be like this. Here you can see this is also sigma bond. This is also sigma bond. This is also head on head overlapping. Another thing, that is the bond will be always make in the same orientation. Like if there's a plus and there is a minus, so there will be no bond between them. If there's a plus and there's plus, there will be the bond will be in same orientation always. If either it's sigma bond or either it's pi bond will be always in same orientation. Like here the plus, then the bond will be there. Like the bond in the minus there will be also bond. So in PS we are also having sigma bond. Like here is also a head on head overlapping. Now if we talk about the overlapping in P and P orbital, so that will be like this. This is a P double shape. This is another P. When they will get overlapped, like this. So this will be called the pi bond. But in PP you will see here in P and P there will be also the sigma bond like this, because as we all know that in P and P we are having PX, PY and PZ. So in the PX will be always the sigma bond, and PY and PZ will be always the pi bond. Here you can see this is a y-axis, this is a lateral and this is a parallel. So this was a pi bond. Now if we talk about like this, PX will be always like this because it's on x-axis. When they both get overlapped, like this, so this will be called sigma bond, which means this is called sigma bond, which means in P there are some exceptions that it will not make only pi bond or only sigma bond. In PX we will be having sigma bond. In x-axis there will be always sigma bond, and in in PY and PZ, because PY is like this in lateral, we can say parallel, and PZ is also like this, so that will be called the pi bond in PY and PZ. After that, if we talk about the characteristics of sigma and pi bond, what will be the characteristics of sigma and pi bond? First of all, why we use sigma and pi bond? Because sigma and pi bond tells the bond strength, bond energy and bond length. After that we will see the characteristics. Here sigma bond, here pi bond, will be the characteristics. First of all, in sigma bond there will be maximum overlapping. As you can see, this is a sigma bond, so this will be the maximum overlapping. Maximum, as you can see, there will be the maximum overlapping between the head-on-head overlapping in sigma bond, but in pi bond, that is side by side overlapping, so that will be the minimum overlapping, like this. You can see here, like this is a pi bond overlapping like this. This will be the less overlapped, or we can say minimum overlapping. Minimum overlapping. After that, another point is that is sigma bond will be more strong. Sigma bond will be more strong. Sigma bond will be more strong, and the pi bond will be less strong, or we can say weaker bond, or weaker bond. After that, another point is that according to VBT, VBT means valence bond theory, extent of overlapping decides bond's strength and bond energy. Like extent of overlapping, which means we can say the how the bond is stronger or the bond is weaker, so that will be told by the bond strength and bond energy, which means extent of overlapping. Like the extent of overlapping will tell the bond strength and bond energy. After that, in this, as I told, that maximum overlapping, so here's the point that overlapping is directly proportional to the bond strength. How? Because if the bond strength, maximum will be the overlapping, so the maximum will be bond strength in sigma bond. Minimum will be the overlapping, minimum will be the bond strength. So that's why overlapping is directly proportional to the bond strength. After that, that if higher energy is there, so the bond strength will be smaller. Bond strength will be smaller, which means if there is a high energy in the orbitals, so the bond will be very smaller, we can say very weak, which means a bond strength will be smaller if the energy is higher. If the energy is lower, so the strength will be lower. In this, we are having higher strength, so which means we are having low energy in this. And this we are having high energy. After that, we are having one point that is like this is the axial overlapping. Here you can see the length is shorter, length smaller, but in this you can see the length is higher. Like if the bond will be higher overlap, so the length will be smaller. If the bond will be less overlap, so the length will be higher, which means the bond strength is directly proportional to the bond length. Because if the bond length will be smaller, then the bond strength or bond will be more stronger. If the bond length is smaller or higher, so the bond strength or bond will be the weaker bond. So that were the characteristics of pi at sigma bond. But one another thing that here I am right, that the first bond will be always sigma bond. Like the first bond will be always sigma bond in any element. Like if I give an example, here you can see ethene, like so here first bond will be the sigma bond is denoted like this. I'm making like this will be the sigma bond, first bond will be the sigma bond. Here first bond will be the sigma bond, here first bond will be the sigma bond. Here first bond will be the sigma bond, but second bond will be the pi bond. Always first bond will be the sigma bond, then second bond pi bond. Always here will be the second bond pi bond. As you can see, water is like this, H O and O. So here will be only sigma bond, because here is only one bond, only first bond is there. So here will be a sigma bond, no pi bond in water. So that will be the first bond will be always sigma bond. So that was the characteristic of sigma bond and pi bond.